Okay, so we'll take a look at the product rule here and how we could use this. Now, this is, being that it's squared, right? What that really means is we are starting with this. We have x minus 2 over root x times itself. So we do have a product. F, the first function, is this. G, the second function, is identical. But nevertheless, f and g. So the product rule, if you recall, if you have a product of two functions, whether they're the same or different, doesn't matter. It's like this: derivative of the first times the second plus the first times the derivative of the second. So one little step we might want to do here before we start taking the derivatives is maybe let's simplify this term right here. Would you think? Okay. So instead of this as a quotient, 2 over the square root of x, or divided by, let's write this as a single monomial term with a negative exponent. So what would that look like? It's going to be x minus what? 2 times x to the negative 1/2. Everyone see that? Oops. There we go. I'm going to change this one too, obviously. So minus 2x to the negative 1. Are you guys okay with that? Right? You get that? Okay, so now we're at a spot where we can take the derivative, so let's find the derivative here. So we want to do the derivative of the first, okay. So what's the derivative of the first? Okay, well, this is going to be an expression. So this is going to be 1 minus, so this power rule here, right? This comes down, so that's actually going to be negative 2 times the negative 1/2, so it's actually going to be plus. What's 2 times 1/2? Is 1. And then this is negative 1/2 minus 1 is negative what? Negative 3 over 2. Okay? So you have negative 1/2 and you subtract 2 over 2. That's negative 1 minus 2 is negative 3 over 2. Okay? So we've got derivative of the first times the second. So we don't touch this one. You just leave it alone. Okay? Plus the first, so it's just this one right here, times the derivative of the second. Well, we already took the derivative, right? We already know what the derivative is, so it's just like this. Okay. Now, I know this is looking pretty nasty so far, but you know what? At times, calculus is nasty. It's a little messy. This actually isn't that tough, and I'll show you why in a second. Because this is squared, because each of these terms are the same, do you realize that this is the exact same as this? Okay? So really what we could do is we could write this as, you know what, y prime is 2, if you want, times 1 plus x to the negative 3 over 2. That was x to the minus 2x to the negative 1/2, right? Because we're adding 2 of the same thing, so it's just 2. Could do that. I don't know if that's going to make things simpler, but if you are thinking about, because now what we're going to have to do now is do the FOIL method and expand out, so you don't have to expand so much now. Okay, so let's expand this out and simplify. This is okay for saying, you know what, this is kind of like lower level differentiation. This is it. This would be enough for, you know, certain types of questions, especially if you're saying at, you know, x equals 2, okay? You could stop anywhere here. Like you could stop at this line right here and just plug in x equals 2 here, 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 and here. Plug in x equals 2, put it in your calculator, you get a value. But if we're asked to simplify this, what we want to do is we want to expand everything we can, gather all the like terms we can, and write this as a polynomial if we can. So let's expand and see what happens. So I'll leave that 2 out there for now. Let's do a little FOIL method. So that's 1 times x is x. This would be minus 2x to the 1/2, to the negative 1/2. Now we're going to multiply the inside guys here. So this is actually x to the positive 1. So when we multiply terms that have the same base, what do we do with the exponents?
Add them.
Yes, you add the exponents. Good. So this is going to be plus x to the power of, what's negative 3 over 2 plus 2 over 2? Yeah, negative 1/2. Okay. And then the last terms here, this is going to be minus 2. This is going to be x to the power of what? Well, now we have to add this number and this number. So what's that? Negative 3 over 2 and negative 1 over 2 is negative 4 over 2 or negative 2. Okay. So, yeah, all right. So this is, I don't know what you're thinking about this. If this is gross or if this is okay. I mean, it's algebra. That's all it is. This isn't calculus now. This is just algebra, right? Gathering terms and writing stuff, right? Who?
Yes.
Right? So can we gather some like terms here?
Oh, yeah.
Yeah.
We have x to the negative 1/2 terms here. We have a negative 2 plus 1, so that's a minus 1, x to the negative 1/2. This is then so minus 2, x to the negative 2. I can multiply my 2 in now. I get 2x minus 2x to the negative 1/2 minus 4x to the negative 2. And finally, probably what you want to do to simplify, to make some space here. Oh, that's great. What you want to do to simplify is you're going to want to write exponents with positive exponents, not negative exponents. So what you might want to do at the very end here is to write this as 2x minus 2 over root x minus 4 over x squared. Okay? Whoa. And that should be your derivative for that question. Okay. Now, okay, I mean that's calculus. That's how you find the derivative. And again, if you want to find the actual slope of the tangent line to this function, you just at any point you simply plug the point into this expression for the derivative. Okay. All right. Any questions about that?